Alrighty, well, we'll get started. For those of you that don't know me, I'm Jim Adamski with Roth Sugar Bush. So, give you a little background on myself. My family and I own and operate a small commercial sugar bush up near Anigo. So we have 10,000 taps there on vacuum tubing that we manage. Been making syrup for this will be my 42nd year. So been at it a couple of years. So we're going to start kind of with the beginners clinic. That's the first place we're going to start. Okay, so the biggest thing we always get asked is what trees can I tap? So there are about 23 different species in the maple family that fall into that maple category. But we're really going to talk about four particular species that are really available here in the Midwest for syrup production. So the four that we're going to talk about are the sugar maple, the black maple, the red maple, and the silver maple. So in the Midwest, that's going to be the four primary species that we're going to use for making maple syrup. So when we look at the sugar maple, this is the region or the range in which the sugar maple thrives in the U.S. I will say that climate change is real and it is happening. We are starting to see this south boundary of the sugar maple range slowly start to make its way north. So we are going to see that range shrink up here in the next 50 to 100 years. It's definitely moving north. So, like I say, it's happening and we're starting to see it a little bit more and more as the years go on. When we look at the sugar maple, it's easy to identify by the bark. On the mature trees, the bark is dark brown, has pretty well-developed vertical grooves and ridges. If you look at the picture down on the bottom, it is our traditional 5-lobe leaf. So like I say, very, very easy to identify by the bark and by the leaf on the tree. When we look at the twigs on the sugar maple, you'll see the twigs, the buds up here are located across from each other on the twigs of the sugar maple. They'll be 1/8 inch to 3/8 of an inch long, conical and pointed, brown in color. Like I say, pretty easy to identify. The seed on this particular tree will usually come off in pairs. We're going to see that maturing in the fall. So like I say, those are another way to identify by the twig and by the seed. The next one we're going to talk about is our black maple. So black maple is not really a common species up here in the Midwest, or in the upper Midwest, I should say. You see the little green dot that we see up here in central Wisconsin. We have about 157 acres of maple woods at our place, and we have one black maple in the mix. That's all we have. So it's kind of a rare site up here in the Northwoods. You get down into southern Wisconsin, it becomes pretty common to see that black maple mixed into the stands. Easy to identify. Bark's going to be just a little bit different than the sugar maple. It's going to be a little finer groove, kind of a little platier on the appearance. We're going to go from that 5-lobe leaf more over to a 3-lobe leaf, which you can see down here in the left corner. When we look at the black maple, the buds are going to be on the ends of our twigs. You can see the buds will be right on the ends. They'll be conical, brown in color. Seed on this particular tree is going to fall off in singles, not in pairs like we see on the sugar maple. And it's going to basically mature in the fall. So this is really kind of the hope for the maple industry going forward, is the red maple. This particular species grows very well from Florida all the way up into Canada. So when we look at a tree that's very resilient to climate change, this one's going to be kind of our future. When we look at the sugar maple tree, we always kind of refer that as the Goldilocks tree. Doesn't like it too wet, doesn't like it too dry, doesn't like it too hot, doesn't like it too cold. So it really is kind of finicky on where it grows. But when we look at the red maple, very resilient, can grow in a lot of areas, a lot of different soil types. It can grow on relatively sandy soil to, extremely wet river bottoms. So like I say, this is kind of our change for the future going forward is going to be our red maple. So we look at the bark on the red maple. It's going to be light gray kind of in color. Bark is traditionally smooth on the smaller trees. When you get into the larger red maple trees, the bark might appear almost platy or scaly and kind of wanting to peel off the tree. We're going to be back to our traditional 3-lobe leaf. We're going to see down here on the bottom with some relatively fine serrations on the edges of the leaf so you can tell the difference. When we look at the red maple, our buds are going to be kind of puffy or clustered. If the upper picture there is going to show our buds. When we go down to the bottom side, that's going to show our seed. Seed on this particular tree is going to mature early in the year. So it's going to come off the tree late May, first part of June. So a lot of times if somebody's been out tapping trees, well, they'll get the opinion that I don't want to tap that red maple because it wants to bud out right away in the spring. Well, that's really not the buds that you're seeing right away in the spring on these trees. The first thing that the red maple tree is going to do in the spring is it's going to flower. And that redness or that red hue that you see on the top of the tree is actually going to be the flowers, because the first thing this tree does in the spring of the year is going to reproduce and create the seed. So what it's going to do is it's going to blossom. It's going to create the seed, and then, like I say, the seed will fall off this tree usually end of May, first part of June here in central Wisconsin. So that's really kind of the difference between the softwood varieties versus the hardwood varieties in the maple. Silver maple is another very resilient tree. It's really quite amazing. We see a lot of syrup production taking place down in southern Missouri using silver maple, which is really quite interesting. We've put a lot of equipment down into that neighborhood the last few years. So, like I say, very resilient tree, can grow in a wide variety of climates. So, like I say, this is another good species going forward. That could be tapped for syrup production in the U.S. So. When we look at this particular tree, this bark is going to look just a little bit different. The bark will be kind of a gray color, perhaps have a reddish tint to it. Like say, more of a platier appearance. Then we're going to go back to more of a traditional 5-lobe leaf, like you can see down here on the bottom. When you look at that leaf in the summertime on the tree, if you turn that leaf over, you will see a kind of a silvery or a whitish underside of the leaf. So hence the term silver maple comes forward. It's easy to identify by the bottom of that leaf in the summer. Same thing, buds are going to be puffy and clustery. And then, like I say, the first thing that this tree is going to do in the spring of the year, it's going to flower, it's going to reproduce, make its seed. And then, like I say, seed is going to fall off end of May, first part of June. So that's really kind of the 4 primary species we're going to look at for syrup production in the Midwest, and really how to identify those particular trees. So. Okay, so why is sap sweet? Okay, throughout the summer months, that tree is conducting photosynthesis. So basically, it's taking that light and that energy in. It's going through the process of photosynthesis. That particular tree is going to make starch. That starch that is generated throughout the summer months is going to be stored down in the root system of that tree. As we get closer to the fall, or when the weather starts cooling off, that starch is converted over to sugar. And then that sugar is taken up through the tree and basically feeds that tree through the winter months, okay? So typically, the larger the tree, or the more leaves and limbs that a tree has on it, the more photosynthesis that it conducts, the more starch it can make, the more sugar it can make. If you're a hobby producer, say for example, and you just want to tap a few trees in your backyard or whatever the case may be, pick on some trees that are kind of all out by themselves. The more leaves and limbs that tree has on it, the more sugar it can make, the sweeter the sap should typically be. Sugar content of the tree sugar content of the sap varies by tree. There is a little bit of truth to that, but really the sugar content is a product of the tree's environment. So I'll give you an example. I've got a water bottle that I use for about 100 different examples in this presentation. So if you picture this as your tree, and if 75% of that tree is covered in leaves and limbs, it's like a giant sugar factory. It'll make a lot of sugar. So when I was a kid growing up, my grandfather said, well, you shouldn't tap the softwood varieties, the reds or the silvers, because the sugar content is lower. It's not really the case. We have a red maple in the backyard of our sugar house that's a 5 Brix or a 5% sugar in the spring. But that tree is all out by itself. About 75 to 80% of the stem of that tree is covered in leaves and limbs, so it can make a tremendous amount of sugar. So that tree has, like say, very sweet sap. So when we look at trees themselves, they're more of a product of their environment where they're located. That's going to dictate a lot of the sugar that's coming out of that tree in the spring. So what's going on internally inside that tree? So if you see the slide over on the left, basically when we go below freezing, that tree goes into a state of vacuum. So in the fall, when our weather is cooling off, we drop below freezing, that tree goes into a state of vacuum, and it draws that sugar up the stem of that tree. And by drawing that sugar up the stem of that tree, what happens is we protect that tree from that cold weather, or we're feeding that tree through that cold weather. Now, the opposite takes place when we go back above freezing. The slide over on the right, the tree is basically under pressure. We're forcing the sap back down the stem toward the root system as our temperature rises. So if you're tapping on gravity methods of production, like bags and buckets or gravity tubing, we really need to see that freeze thaw process to move that sap internally inside that tree. Okay, so we're going to talk a little bit about atmospheric pressure and how that plays into syrup production. With high atmospheric pressure, if you picture the sapwood of a maple tree as a giant sponge, the higher the atmospheric pressure is, the more pressure we put on that sponge, the smaller the pores get in the sapwood. The opposite takes place, of course, when we go into a low pressure situation. We take the pressure off the sapwood, the pores get bigger, the sap wants to free flow out of that tree a lot easier. So how many people in the room are currently making syrup or have made syrup? Okay, few. So what happens is when we go above freezing, say for example, and it's a nice, bright, sunny, clear day, and you go out into the wood lot, and by 1 o'clock in the afternoon, the trees quit running. Okay, they just slow right down to nothing. And you're trying to figure out, okay, what happened? You know, we froze really hard last night. We should have had a nice freeze thaw process to fill the stem of that tree up with sap. We came back above freezing today. It got nice and warm. It's bright sunshine. There's not a cloud in the sky. So usually what happens on days like that is we see very high atmospheric pressure. So what happens by, mid-afternoon, that tree has got enough outside force on it or enough atmospheric pressure that I'm slowing down the flow of sap or almost preventing that flow of sap if the atmospheric pressure is high enough. So the same thing happens when we have a low pressure situation. So say, for example, I froze up the night before and I was below freezing for a prolonged period of time. The next day I warm up and I have either a spring rainstorm or a spring snowstorm. And what happens is that tree is put into that low pressure situation with that incoming weather. So I relieve the pressure off that sapwood of that tree and I get a pretty good run of sap. Even though the weather is really kind of crummy, it's going to be snowy or rainy, whatever the case may be. So atmospheric pressure really does play into, how that sap is coming out of that tree. So now me as a commercial producer, we use vacuum, of course, to assist with our sap collection. So we're putting that tree into a low pressure situation kind of on a daily basis. We're taking that high atmospheric pressure out of the equation. We're putting that low pressure situation onto that tree. We're letting that tree flow that sap out of that sapwood. So that's really kind of the difference between gravity methods of production and vacuum production. So there are some other factors that influence the run of sap. One is linked to the freeze thaw process. So say, for example, it's 6 o'clock in the evening, I go below freezing, and I don't go above freezing until noon the next day. So that tree was in a very long state of vacuum. It could draw a tremendous amount of sap up the stem of that tree, okay? So when I go back above freezing the next day, I have a large volume of sap inside that tree that I can force back down that tree. So I had a long freeze process. I had the opportunity to get that, large volume of sap. The next day I should have a pretty good run. So the same thing, kind of the opposite, really happens when we have a short freeze thaw. So say, for example, it's getting later in the spring and I might not freeze until, say, 3 or 4 o'clock in the morning, and I only drop down to maybe 31 degrees and I'm only below freezing for an hour or two. Well, that tree didn't have a long or a very good opportunity to draw a large volume of sap up the stem because it was only below freezing for a couple hours. So when I go back above freezing after a really short freeze cycle like that, I'm not going to get a lot of sap. Okay, so that's kind of how that freeze thaw process works when it comes to the maple tree. Wind, of course, we get out in the large stands. We got a lot less wind in the large stands. If you're going to be tapping on some edges of some wood lots or some trees in the backyard or whatever the case may be, wind is an important factor. We'll get a cool breeze on the trees. It'll definitely slow our production of sap down. We discussed atmospheric pressure kind of in detail over the last slide. Microclimate of a region. So, here in central Wisconsin, we have Lake Superior, of course, to our north. We have Lake Michigan, of course, to our east. In the spring of the year, if we catch a wind out of the north, northeast, or east, and the lakes are pretty much froze over, we can see quite a bit of a reduction in our temperature, which will also result in a lower sap yield. So, like say, kind of watch the microclimate. So our office is based out of Cadott. Like say, I make syrup up near Anigo. A lot of times, I'll talk back and forth to the store several times throughout the course of the day. We might be, 46 degree, or they might be 46, 47 degrees over in Cadott, and sunshine will be sunshine and 38 degrees with a north breeze coming off Lake Superior, or coming off that giant block of ice up there. So, like I say, we kind of have the lakes influencing our climate here quite a bit. So, snow coverage or frost. As a syrup maker, I really don't like to see a lot of frost. Okay, I like to get snow around Thanksgiving time, and I'd like to keep it until spring. That would be my ideal scenario. So, what do we know about the maple tree? All of our sugar is in the root system. So if I go out in the woodlot and I set a foot of frost in the woods, and because a maple tree is a very shallow rooted tree, and I freeze that massive root system up pretty much solid, I'm not going to get a lot of sap out of that tree until that frost goes out of the ground or that root system thaws, that I have access to that sugar. Okay, so like say, if you are tapping some trees in your yard, along a driveway, say for example, you may tap that tree and it might not run any sap until the season's just about done. Well, we had to wait for the frost to come out of that section of ground by the driveway where the frost was pushed in deep throughout the winter, and that tree might not run until later in the year. So, like say, as a sugar maker, I don't necessarily like to see frost. Like say, I'd rather see that snow cover. Precipitation level, coming off drought years, we typically see a little elevated sugar because the tree doesn't have as much moisture to work with. So looking back to the spring of '89, coming off the drought of '88, looking at the spring of 2013, coming off the drought of 2012, we did have some fairly good production years with a little bit of an elevation in our sugar content, just for the simple fact the tree didn't have a lot of extra moisture to work with. So that's how precipitation level kind of factors into to the run of sap. So
when people say that lack of moisture, that lack of precipitation, that using the vacuum tubes actually hurts the tree. I mean, they're saying that without evidence, of course, but they're saying almost does that hurt the tree, that we have a one-off where you don't get any snow or rain like now so
well,
this year.
yes.
What's that long term, or how does that work using vacuum when there hasn't been much precipitation?
So, University of Vermont has got great research on this. So they've got a research project that's been carrying on for probably 15 or 16 years already, and it's an ongoing research where they have a group of trees here that are not tapped ever, and that's just the control. That's the standard forest, and then they've got a group of trees right next to it that are tapped on high vacuum. So what they do is basically every year they go through and they core the trees, they check the growth, they check, basically, visually check the health of the trees. And over the last, it's either 13 or 15 years that they've been coring these trees, they see no statistical difference in tree growth or tree health from this lot that's tapped on high vacuum to the lot that's not tapped at all, even with bags or buckets. So they're not seeing a real, statistical difference from one to the other. Now, the thing you got to remember, when we harvest sugar out of these trees in the spring, we're not taking the sugar that was just made last year. Okay, so the sugar that we're taking is sugar that has been gathered over a period of years. So like, say for example, like last year was a drought year and that tree had a lot of stress. Well, we're not harvesting just that sugar that was made last year. We're harvesting sugar that was made probably over the last 10 years. So when we look at a 1 or 2 or a 3 year, stint where we have too much moisture, we have not enough moisture, we really don't see that variation in tree health, because like I say, that sugar that we're harvesting is excess from the tree, and it's given out over a period of time. I hope I answered your question that you were looking for. So,
Yeah, that's something we have to answer as well.
mhm.
People ask.
Yep. And we've seen some really bad drought situations that happen. I look up in the Arrowhead of Minnesota. There was a period of probably 7 years where there was some extreme drought up in that area, and we did see a little bit of decline coming in some of the sugar maple stands, regardless if they were tapped or untapped. And it was an ongoing drought. I think it was probably 6 to 7 years in length. And they have come through that cycle now. We did see some decline in those trees, but it's amazing how those trees bounce back in the last 3 to 4 years. It really is quite amazing. So that tree is pretty doggone resilient. It's quite amazing. So okay, so that's a little bit about flow. Okay, so how many trees or how many taps per tree? So when I measure a maple tree, we're looking at diameter at breast height, roughly the middle of your chest. Okay, so we say a tree that's 10-inch diameter at breast height is going to be a single tap. A tree that's going to be 20-inch diameter at breast height will be 2 taps. And we're never going to tap it 3 times. We're never going to tap it 4 times. So the next presentation that we're gonna do this morning is going to be our tapping presentation. So at that stage of the game, we're going to discuss more of this tapping practices kind of in detail. So we're not going to spend a tremendous amount of time on it right now, but like say 10-inch tree, single tap, 20 inches or over, 2 taps, never 3 taps, never 4 taps. So we always want to locate last year's tap hole. We always want to stay at least 3 inches away from that tap hole to the left or to the right. If we're going to be above or below that tap hole, we want to be a foot above or a foot or below. Like I say, we're going to talk about this in more detail in our tapping seminar. And this is where probably my grandfather gave me the worst advice you could get when you started tapping trees. And that was, just tap on the south side of that tree because it's nice and warm, and that's the side that's going to thaw out first, and that's where you're going to get the best sap. Well, that was probably, like say, the poorest advice that I could have gotten from my grandfather. And like say, we'll discuss that in more detail in the tapping seminar, as far as what's going on internally inside the trees, and why we don't want to do that practice. So okay, so tapping angle. So it's going to show drilling in at a slight uphill angle, 5 to 10 degrees. Just in the last couple years, University of Vermont has done some research as far as tapping straight into the hole without any angle. And there's really no statistical difference in yield from a slight uphill angle to a straight in tap hole. So like say, you can drill at a slight angle if you'd like, or you can drill it straight in. It really doesn't matter. This particular example is going to show a depth stop on a drill bit. I brought in a drill. I don't use any depth stops in my woodlots. We just use a standard tapping bit on a drill. So when we talk about depth stops, we really want to talk about the stand of timber that you're in. So there's 2 really stands of timber that we can talk about. One's going to be an even age stand of timber, and one's going to be an uneven age stand of timber. So if you walk out into that woodlot, and every maple tree that's in that woodlot, say for example, is 18 inches in diameter, and every tree you look at is that size, we're going to call that an even age stand of timber. In that particular case, I would say a depth stop would be an acceptable piece of equipment to add to your drill bit. But now if I'm going to tap into an uneven age stand of timber, and by an uneven age stand of timber, I mean there'll be a 12-inch diameter tree there, an 18-inch diameter tree there, there might be a 48-inch diameter tree here, and a 30-inch diameter tree here. Every one of those trees is going to have a different thickness to the outside bark. Okay, so when we get into some of these really large 30, 36, 48-inch diameter maples, that bark layer may be very thick. Okay, so depending on how deep you have your depth stop set for your drill, okay, say for example, you got that set at 1.75 inches. If I've got that depth stop on there and I go up to that 48-inch diameter maple and I drill into it, 1.75 inches deep, I might not hit good white wood. I might not have made it through that real heavy bark layer on those trees. So this is one of those things, next time a tree blows down and the woods are in the woodlot where you're tapping and you're going to cut it up for firewood, buck off some blocks, look at how thick that outside bark layer is. Make sure that we are drilling in far enough to hit the nice white wood where that sap is flowing so that we can get some yield out of that. So when we talk about a depth stopper, in an even age stand of timber, no matter where I go in that woods, like say in an 18-inch diameter woods, that bark layer is going to be real consistent between all of our trees. But when I hit that uneven age stand of timber and I get into some of them real big trees with the heavy bark layer, depth stop might not be the right tool for that application. So, okay, possible tapping problems. So when we're drilling in with drills, we are, setting round taps. We want to make sure that we are drilling in nice and straight. 2 hands on the drill into the tap hole, come back out. Okay. If I'm tapping up high, say for example, on a tubing system and I drill in, I'll have a tendency to pull down on my drill bit or on my drill when I'm pulling the drill out of the tree. So then I will run into a situation where I can end up with this little bit of an oval shaped tap hole. Same thing, side to side moving in my drill, both hands on the drill, in and out in one motion. Never take the drill back into the hole the second time because we're gonna end up either doing this or that. Whoops, and we're gonna have some issues with the taps not wanting to seal up properly. So. Okay, tapping depth. So, really from a tapping depth, we're going to look at that 1.75 to 2-inch tapping depth. Like say, be mindful of where you're tapping. If you are tapping a lot of large diameter maples that have extremely heavy bark, you might want to tap 2 1/8 on them really large trees just to make sure that we're getting through that heavy bark layer. That's why, like say, if you're an uneven age stand of timber, like say a depth stop might not be the right answer. So like say, we want to make sure we're getting that tap seated into some nice white wood that we are getting a good run of sap out of that tree. So, okay. So one of the things that we run into with people tapping trees is they'll go down to or go out to their garage and they'll get a 32-ounce East Wing framing hammer and they'll take that big old hammer out to the woods to put their taps in. Well, we're not driving spikes, we're setting taps. Okay, so one of the tools, like I say, that works really good is a tapping hammer. It's got a sharp blade on the back that we can remove the moss or lichen from the bark prior to drilling, so we keep a nice clean tap hole. And it's 8 ounces or less. Okay, so it's not very heavy, so it's hard to overdrive a tap into a tree. If we overdrive a tap into a tree, what can happen is we can crack the wood above and below our tap hole, which causes a leak if we're on vacuum. And it also creates a little bit larger wound, and it's going to take the tree a little bit longer to heal itself. Okay, so when we're tapping with, tapping hammers in the spring of the year, wrist strength only. We're not swinging like we're setting tap or driving spikes. We're setting taps, wrist strength only, and we're going to tap some trees here during our tapping seminar. So we'll get a little bit more detail on that as we go along. But like say, smaller hammer, 8 ounces or less. Like say, we don't want to overdrive the taps into the tree. If you are going to get going on some, prior to the run and the trees are frozen, frozen trees will crack a little bit easier than we'll see on trees that are fully thawed. So we have a commercial operation. We get started tapping very early. We're probably going to get started here probably later this week. We're going to get going on tapping. I wouldn't recommend that if you're a hobbyist, of course. Like I say, we just got a lot of taps to get put in. It takes us a while. Our crew is kind of old. So um, if you are going to get going on frozen trees, take a little more care on setting taps because the wood is a little more fragile. And then if you are making syrup on the softwood varieties, our reds and our silvers, that is a softer wood variety. Those trees are susceptible to cracking a little bit more than our black maple or our sugar maple. So like I say, just a little more care when we're setting taps in that softwood variety. So, okay, basic equipment for tapping trees. So we've got our hookless tap over on the left. That can be used with select buckets and bag holders. Our center tap is our traditional bucket holder, bucket tap with a hook to hang your bucket on the bottom. And then we have our tubing tap over on the right, which is designed to basically connect a hose to it. So depending on your method of production, you're probably going to use one of those particular taps. Is what we'll see there. So that's, like say, one of the three items that you'll be using there. Different methods of gathering. We are going to look at a bag holder, which is over on the left-hand side. Anybody know where that thing originated at? Okay, that was patented by a company in Anawa, Wisconsin, just north of here, called Reynolds Sugarbush. So they patented that device in the 70s for gathering sap. At one time, the largest producer of maple syrup in North America was located in Anawa, Wisconsin. They had about 200,000 taps. So they made that device out of necessity. They needed something that was easy to take apart, easy to take apart, easy to clean, easy to put away, didn't take up a lot of storage space. So that was their creation. So yeah, as a kid growing up and tapping trees, I grew up with that device. So yeah, just made up the road from here, not that far away. Um, Picture in the center is one of our sap buckets. We don't see a lot of metal buckets being used anymore, of course, to make sure that we keep our food safe. We've tried to eliminate, any galvanized or lead soldered equipment out of our production methods, so that we don't see that lead transfer into our maple syrup. So typically today, if you're going to use a bucket, it's a HDPE, high density polyethylene bucket. That will be BPA free plastic. Very food safe, very easy to clean. And then, of course, if you're going to use some tubing, whether it be gravity tubing or high vacuum tubing, we have our food grade tubing over on the right hand side. So that's really going to be our three different collection methods that we're going to look at using as we're making syrup. Okay, so like say, by today's standards, rechargeable drills are very good. It wasn't that long ago. I think probably 10 or 12 years ago, we were still running a lot of gas engine drills yet, because we just didn't want to carry 30 batteries in our backpack through the woods as we drilled holes. But by today's standards, we can drill quite a few holes with these, especially the brushless models. Like I'm kind of a fan of the Milwaukee brushless. We can run quite a long time on a single battery, so they are very efficient. The second picture in the middle there is one of our tapping bits. I'm not going to call sugar makers cheap, but I'll definitely call them thrifty. Okay, my dad is one of the fellows that is the thrifty sugar maker. He never wanted to buy the tapping bit for $21. He figured they were too expensive. The bits are actually really nice. They have a 90-degree tip on them, so they start on the tree very quickly. They don't walk around on the surface. They have very tight flighting on it, which ejects the chips and sawdust very quickly. They are extremely sharp. So when we look at the interior of that maple tree, picture that stem of that maple tree as a giant series of sugar-filled straws. Okay, so all these very fine microscopic straws go up and down the stem of that tree. When I start to drill into that tree with that drill bit, a nice sharp drill bit, I cut those straws off very cleanly, and it allows the sap to drip out of them very easily. If I take a dull drill bit, or the wrong drill bit, like just a drill bit for drilling regular old steel, when I drill into that tree, I drill in, but instead of cutting the wood fibers off, I kind of tear them and I kind of lay them over. Okay, so when I tear them and I lay them over that as that drill goes around, I kind of clog up my pores in which my sap is coming out of. So a good sharp tapping bit is worth its weight in gold. So the story I got that goes along with that is this is basically the rig that we use for tapping. One day at lunchtime, I chucked a drill bit up in my dad's drill. As we were eating lunch on the back of his truck, he drilled the first tap hole into the tree. He looks at the bit, puts it into his holster, sets the tap in the tree, goes up to the second tree, drills into the tree, looks at the bit again, puts it in his holster, taps the tap into the tree, walks up to the third tree, drills it, looks at the bit and said, "Hey, where'd you get that bit?" And I said, "Well, that's one of those bits that, you didn't want to buy because they were $21 a piece." And he's like, "Well, that's probably the nicest drill bit I ever drilled a tree with." So, at that point he was sold on it, but he had to use one first. So like say, essential tools, when it comes to that. Like say tapping hammer, it's a $22 hammer. It's got, like say, it's got a nice sharp blade on the back for removing moss or lichen off the tree. It's 8 ounces or less. It's got a small head on it, so it's really hard to get crazy swinging because you're going to miss the tap. So, like say, kind of the two essential tools when it comes to tapping trees to really ensure your success out there in the woodlot. So, not sure what's happening here. There we go. Okay. Sap gathering and storage equipment. Okay, so I am very picky about the equipment that we use to make syrup because we are making food. Okay, so a lot of times, we'll see sugar makers, go alongside of the road and they'll see these little plastic cage steel tanks for sale. These 275 to 300 gallon used tanks. You can buy them for $35 or $40 along the side of the road. Those are called a tote tank, and they are meant for transporting liquid one way to a destination, and then they're supposed to be disposed of. Okay. So a lot of times those particular tanks carry some substances that are pretty nasty. So as a syrup equipment salesman, I get to see just a little bit of everything. So we did a tubing project for a gentleman up in northern Wisconsin, and we're getting ready to start our installation process. And I said, "Well, what are you going to use for a tank? I need to know how high to start with your lines." He's like, "Well, I've got these tote tanks over here." And there's a whole stack of them. He had like 15 of them lined up over there. I'm like, "Well, where'd you get these from?" "Well, I got them from the airport because the airline de-icer comes in them, and that's what I'm going to use." Unfortunately, a lot of times when you see these alongside of the road for sale, there's a little steel plate on the side, and you'll see that somebody took a razor knife and scraped the skull and crossbones off the side. That's because there was some pretty nasty stuff that came in them. So anytime you see somebody selling these, oh, they were food grade, they had food products in them. Well, calcium chloride that's used in food production isn't something that you should necessarily eat straight out of a container. So no matter how we try to clean plastic, it is a very porous surface. Okay. I've had customers that have filled them up with hot water and soap and drove around the block 4 or 5 times, sloshing the water around inside the tanks. They think they get them clean. They really don't. Okay. If you are going to buy a tank, keep it for syrup production. Don't, you know, fill your farm sprayer with it in the summertime. Don't mix liquid fertilizer in it for your flowers and water your garden with it. Keep it for syrup production. We are making food. And one thing I will say about using old food containers is 10,000 jalapeno pickle buckets or jalapeno pepper buckets make terrible tasting syrup. Okay. Pickle buckets make horrible tasting syrup. That material is impregnated into that plastic. And no matter how you try to wash or sanitize them, you cannot get that material out of them. You know, the other thing that goes along with that is food allergies. Okay. So when we look at people of my age or older, we don't have a lot of allergies to a lot of things. When we look at generations that are younger than us or younger than myself, we see a lot more food allergies. You know, a great story that goes along with this is I have a son. Well, he's getting older now. He's going to graduate high school this year, but a number of years back when we had a birthday party for him, there was 7 of his little buddies came over to the house, and every one of his buddies that were dropped off had a different, tag attached to him that one can't have milk, that one can't have peanuts, that one can't have tree nuts, that one can't have bread. So the younger generations have a lot more allergies. So we want to make sure that we're not cross-contaminating our syrup with food allergens. So just kind of keep that in mind. So if
That one's 65 gallons.
yeah,
Is that one of the smaller ones?
yep, that's yep. So yeah, we've got 35. Like in that style, we've got 35. 35 gallon would be our smallest one, and we'll go up to 2,600 gallons in that type of tank. So it really all depends, like say what you want. And if what you're looking at is you want to try and find a tank that's got an NSF signature on it. So basically, that's the National Standards Foundation. That tank is suitable for the storage of potable water. It's made out of a little bit better plastic, and it's a little higher quality. It's a little easier to sanitize. So like say you want to make sure that you are using a tank that's a little better quality. When we say using old food containers, if you want to repurpose stainless steel like a stainless steel dairy tank, that's fine. Stainless steel is easily sanitized with phosphoric acid. It is not a porous surface, and you know those type of devices, tanks like that made out of stainless steel, are easy to repurpose. Like say, stay away from chemical storage tanks and that kind of stuff, obviously. But okay, so it's time to talk about processing sap into syrup. So there are a lot of different methods depending on the size and scale of your operation, how you want to do this. So one of the biggest questions that we always get asked is how much sap will it take to make a gallon of maple syrup? So the tool that we use to measure our sugar content is called a sap hydrometer. Okay, so this is what a sap hydrometer is going to look like floating in a clear tube. And you can see right here that our liquid level is crossing right at the 2 line, which basically means 2% or 2 bricks. So that is going to be a liquid that contains 2% sugar. So when we look at that 2 bricks measurement from our sap, what we're going to do is we're going to use what we call Jones' rule of 86. So if we take 86 divided by the reading on our hydrometer, which is 2, it will take 43 gallons of 2 bricks maple sap to make 1 gallon of 66 bricks maple syrup. Okay, so that's going to be a gross gallon of syrup that is not going to be filtered. Okay, the minute that we start to filter maple syrup and we start to take our sugar, sand, and our niter out of that syrup to get that syrup nice and clear, then our volume or our yield goes down because, like say, we're removing that sugar, sand, or niter. So when we look at maple syrup, we need to get it finished to 66 bricks or 66% sugar. Okay, if we are under 66 bricks, our maple syrup will ferment and spoil. Even if we boil it, filter it, hot pack it into a mason jar, if we don't get to 66 bricks, that material will ferment and spoil. Okay, so it really is imperative that we get our syrup at 66 bricks. So maple sap is a perishable product. The faster you can process your sap out of the tree, the better quality syrup you will make. And this is where my grandfather probably gave me my best advice as a kid getting started making syrup. If it isn't boiling, it's spoiling. And there is a lot of truth to that. A lot of times, we'll get asked, how long can I store sap? Well, if the sap temperature is 34 degrees or less, I can store it for 24 hours. Okay, so if you look at those parameters, it is a very short period of time and the sap has to be very cold. There are very few instances that our sap coming out of our tree or that we're picking up out of the woodlot is that cold. So it really is imperative that we get this stuff processed quickly and get it made into syrup. So time to boil. So there's a lot of different ways that we can boil sap into syrup. One, we got to consider our heat source. We see a lot of small wood-fired evaporators or wood evaporators in use today. Propane is another source of heat. At our sugar house, we run natural gas as our preferred method of fuel. The line ran past our sugar house, so it was easy for us to hook on and run that way. Very cheap, very economical. Methods of boiling, like say propane boiler. We can do a wood fire under a sugar pan, or we can do a small hobby evaporator. Those have become very, very popular. So it all depends on the size and scale of your operation of what you want to use for your heat source, and that's really going to dictate how you process your syrup. So we look at our beginner's boiling kit. These typically run on propane. This is not the most economical way to make maple syrup. If we boil raw sap with one of these, by the time you buy the propane, it'll probably be cheaper to go to the store and buy your syrup versus cooking it with propane. With that being said, though, RO technology or reverse osmosis technology has gotten extremely reasonably priced in the last number of years on the small scale for the hobbyist producer. So there are a lot of pieces of equipment out there now that you can put your sap through and you can eliminate between 50 and 80% of the water prior to boiling, which really reduces the amount of fuel that you need to use. So, you can use propane in conjunction with an RO machine and have a fairly efficient and lower cost way of producing syrup. I didn't think we'd sell as many of these as we did, but there are a lot of places in the cul-de-sacs of Chicago, the cul-de-sacs of the Twin Cities, where you can't have outdoor fires, you can't have fire pits or burning barrels or any of that kind of good stuff. So they are kind of restricted to using these devices using propane. So it is pretty common. I never thought we'd see as many of them being used as we do. A sugar pan. So we sell a lot of just sanitary welded 304 stainless steel pans, and people build their own firebox under them. Whether they build a firebox out of an old barrel like a barrel stove, or they'll make an arch out of cinder blocks, and they'll set the pan on top, and they'll burn wood for a heating source underneath. So, like I say, we see a lot of these being used in this fashion. The other thing we see is hobby evaporators. Hobby evaporators for small scale producers have gotten relatively inexpensive. The newer ones are all made out of stainless steel sides, which pretty much will last you a lifetime if you take care of them. So, and they are pretty reasonable compared to what we saw years ago. So, we do see quite a few hobby evaporators being used in the on the small scale production. So as syrup boils, occasionally it will foam up, and we recommend that you do use an approved maple defoamer to knock down your foam. So when I was a kid growing up on the farm with my grandparents, you took a tablespoon of heavy cream, put it in the syrup to knock the foam down, a pat of butter, whatever the case may be. Our neighbors used to hang a slab, couple pieces of bacon over the top of the pan, and the bacon grease would drip in there and knock down the foam. We really don't want to use those practices anymore. I mean, you can surely use them if you're going to consume all the syrup yourself. That's fine, and you want to do that. That is entirely up to you. But the minute that you give that syrup to someone as a gift and they eat it, and you don't know if they have food allergies, that's where the problems come in. So if you are a licensed producer in the state of Wisconsin, we are required to use a food grade defoamer by Wisconsin law, just to make sure that we aren't cross contaminating our maple syrup with anything else. So I am an organic producer, so I use an organic safflower oil as my defoamer. That's really about all we can use in the organic market. That's really about the only thing that's approved for organic production. And remember that we only want to use enough defoamer to take the foam down in the syrup. Okay, we don't want to take the defoamer bottle and just put in a spray of defoamer to knock the foam down in the pan. A drop or two is usually all you need to knock the foam down. If we use too much defoamer in our syrup, we will pick up kind of a waxy flavor to our syrup when you taste it. You'll taste kind of that waxiness to it. So, like I say, just use enough defoamer to knock down the foam and keep the pan from boiling over. So, okay. So when we look at boiling, here's kind of another two devices that are very common. Yep. Go ahead. Okay. So, like I say, a hydrometer cup is the device over on the left, and a maple syrup hydrometer is over on the right. These are kind of two essential tools. The sap hydrometer that we talked about before will work in this same cup as well. And like I say, the cups are made out of stainless steel. Unless you forget it in the driveway and drive over it with your vehicle, it's pretty hard to wreck one of these. So, I mean, you'll have it for a long time. They're made out of stainless steel, sanitary welded. Hydrometers, on the other hand, are a little more sensitive device. They are made out of glass with a weight in the bottom. And what we're doing is we're measuring the specific density of maple syrup to make sure that we have it finished properly, okay? So like say, two items that are really kind of critical. So there's the lines are specific to themselves. So the top line will be our hot test line. That will be syrup at 211 degrees. When the liquid floats on this line and the syrup is 211 degrees, the syrup is done. Now the bottom line is what they call a cold test line, and that will be syrup at 60 degrees. Okay, so those are the two set temperatures on that hydrometer. So you can cold test your sap at 60 degrees. It should read on that line. Hot test at 211 degrees should be on the top line. So really, Shane, by the time I take a sample out of my pan, fill up my cup, by the time I get my hydrometer set into that liquid, it's really close to 211 degrees. Okay, so you'll be able to check it that way. Now, if you fill your hydrometer cup up and it sits for a prolonged period of time and cools off, when I put that hydrometer in, it's definitely going to read a little bit different. But if without using a thermometer to measure your temperature, if you take a sample out of your pan, time you get your cup full and get your hydrometer in there, it's pretty close to 211. So
just as long as that top line is over your.
Yep. So you want that top line to be right at the surface of your liquid. Okay. And then that'll be 66 bricks.
Right at the line or maybe a little bit over that line.
We're going to discuss what going over does. Yeah. So yep. Good questions though. So like I say, that's the two devices. So when we go to the next page, how critical is this measurement? Like I've mentioned before, 66 bricks or less, syrup will spoil. So even if I hot pack it in a syrup jug or a mason jar, whatever the case may be, if I'm not at 66 bricks, I'm going to ferment or spoil. And what will that taste like? You might actually pick up kind of like a fruity flavor to your syrup if it wasn't put away, at the proper bricks, because it's, going through that fermentation process. Unfortunately, Gary, it's not going to ferment enough to do any of us any good, so don't get any ideas. So, all right. So Shane, if we go over 66 bricks and we go up to 68 bricks, what happens is our sugar in our container gets too dense and it doesn't stay in suspension. So if you ever made a bottle of maple syrup or seen a bottle of maple syrup where we grow a layer of sugar crystals on the bottom of the container, that usually means that our syrup was overcooked. So what happens when we get over 68 bricks, the sugar can't stay in suspension and it settles out of the liquid to the bottom of the container, and then I grow that layer of rock candy across the bottom. So you can be just a little bit over your red line, but if we go too far, that's when we're going to see that rock candy grow on the bottom of that container. So just that's the difference. So we can go 66, 67, 68, but the minute that we touch over 68, we're probably going to grow some rock candy in the bottom. And nothing wrong with that. It's not going to spoil. You can eat the rock candy that's on the bottom of the container. There's nothing wrong with it. Just like say, we're just going to grow the sugar on the bottom. So okay, like I said, 1 bricks below, like say, sap is really thin, very watery. 1 bricks above, 67, syrup is going to be a little bit thicker, and it's going to give the perception that it's actually a little bit sweeter. So if I was a hobbyist and I was going to shoot, to make my syrup, I try to shoot for 67 bricks, somewhere right in between. And like I say, just make sure that I'm getting that syrup done. Making syrup is a lot of work. We want to make sure that it doesn't spoil. We get it put away correctly. So, okay. Alrighty, so say for example, I don't have access to a hydrometer and I need to finish a batch of maple syrup. I can finish a batch of syrup with a thermometer, okay? But I need to calibrate that thermometer in boiling water at my location on that day. Okay, so what do you know about thermometers? Every one of them is going to boil at a different temperature. That's just the nature of the beast. There's no two thermometers really kind of stay the same. We've boiled an awful lot of them, and Unfortunately, to make food safe, they took away the good thermometers, which are our old mercury thermometers from years ago. Those things were spot on. But like say, to keep our food safe, we can't use them anymore. So boil it in water at your location on that day. So what changes the boiling point of water? Atmospheric pressure and elevation above sea level. Okay, so every day the boiling point is going to change just a little bit based on our atmospheric pressure. Your elevation will always be the same at your sugar house, hopefully, but like say, your atmospheric pressure is going to change your boiling point. So put that thermometer into a kettle of water, let it boil for a number of minutes, get a good rolling boil on it, record that temperature. And then once you've recorded that temperature, if you add 7 degrees Fahrenheit to that reading from that thermometer, that will finish your syrup at 66 Brix by adding 7 degrees on. So like I say, if you don't have a hydrometer, you can finish it with a thermometer, but it is really imperative that you boil that thermometer in water on that day at your location. So, okay, filtration. So we really want to make sure that we filter our syrup prior to putting it into a container. We want to make sure it's free of sugar, sand, or niter. If we don't filter our syrup and get the sugar, sand, and niter out, a lot of times what we'll notice when we take a taste of that syrup is it will taste kind of sandy, almost gritty, and that's that sugar sand that's in that syrup. So you'll pick up that kind of that sandy taste to your maple syrup. So what is sugar sand? So I've got this nice clear liquid on my tree, and now all of a sudden I'm boiling it, it starts to become cloudy. Well, basically what's going on is we're condensing those, that calcium and the magnesium salts of maltic acid, the phenolic compounds. We're combining all these ingredients. We're condensing that liquid by removing our water from it. So our liquid goes from that nice clear liquid to a cloudy liquid. Okay, so basically these salts are forming during the evaporation process. And, like I say, it's everything that's coming out of the tree natural. It's just as we boil it, it starts to get cloudy. So one thing to remember is anytime that we reheat syrup over 200 degrees, we can make sugar, sand, or niter again. So say, for example, I've got a batch of syrup and I filter it up and it's crystal clear. I can see through it. It's nice and clear. And I put it back on the stove. I bring it back to a rolling boil and then I pour it into my glass jars and I hold them up and it's all cloudy and hazy. What happened? Well, I put it on the burner. I brought it back up to a rolling boil. I went over 200 degrees. So then at that stage of the game, I developed that sugar, sand, or niter again, and then my syrup is cloudy. So once I get my syrup finished off and once I get it filtered, I want to make sure I keep that temperature of that syrup under 200 degrees so that I don't make that sugar, sand, or niter again. Okay, so what will it look like? Sometimes it'll settle to the bottom of a container, look like a layer of dirt. Sometimes it'll stay in suspension, and like I had mentioned, it'll give that syrup that cloudy appearance. Sometimes it may look like a thick, oily substance, kind of dark in color, and sometimes it'll look very grainy, almost like beach sand on the bottom of a container. So, like say, sugar sand will take on many different appearances. So, like say, how do I get it out of my syrup? Well, one method is to let it sit for a prolonged period of time. Let all the sugar sand and or niter sink out of it or settle down to the bottom. Pour off the nice clear syrup on top and bottle it. Well, unfortunately, we work way too hard making syrup. We don't want to throw any of it away if we don't have to. So we really look at filtering it. So when I was a kid, my grandmother had a recipe of egg whites in cream and milk and stir that concoction into your syrup. And it would kind of coagulate all that sugar, sand, or niter, and it would float up to the top. You skim it off with a skimmer, pour it through a cheesecloth to filter it, and you had some pretty nice clear syrup without doing a lot of filtering. Unfortunately, at the time, it didn't really, we weren't really concerned about allergens. We were putting milk and eggs into our maple syrup, and by today's standards, we really don't want to do that. So, like say, if you come across this recipe out on YouTube somewhere, probably you want to use the syrup for yourself, you're perfectly fine doing it. But like say, the minute that you give that syrup to a friend or a relative or somebody that may have a food allergy, we want to try and stay away from that if we possibly can. So Maple syrup is a very safe product. I mean, the instances of foodborne illnesses with maple syrup are almost zero. It is a 66 Brix product, which is 66% sugar. So there are very few pathogens that can grow in anything that sweet. So that's why we see maple syrup as such a safe food out there in the marketplace. So when we look at filtering syrup, one way we can do it is filter bags. Of course, the better way to do it is a filter press. If you're a hobbyist and you just want to filter some for yourself, filter bags are probably going to be the most common used option from a hobbyist point of view. So when we talk about filter bags, it's really kind of referred to as gravity filtering. Bags will be made out of wool, Orlan, or felt. That's really the three products that they're made out of. By today's standards, pretty much everything is Orlan with maybe just a little bit of polyester. So that's really the fabrics that we're using today. Bags should be dampened before they are used. So if we have a filter bag that we're going to filter our syrup through, we should really, like say, have them dampened before we use them so it's ready to take that sugar sand out. Wash with hot water only, no soap or bleach. So maple syrup picks up flavors from anything it comes in contact with. Okay, maple syrup is really kind of a notorious food for picking up flavors that are a product of its environment. A great example of this is so I had a customer that had a little sugar house kind of setting out in his woods, and you pop open the door of that sugar house in the summer and you walk in the door and it's kind of a musty, woodsy smell to it. That's what you'd smell inside that building, and that syrup that was made in that building took on that smell. So it really, syrup is really kind of a product of its environment. So if your filter is stiff, it should be, it was probably not dry when it was put away. So one thing I will say about filter bags is when we say wash with hot soap or water, or hot water only, no soap or no bleach. Um, like I said, as a syrup equipment salesman, I get to try everybody's syrup because everybody makes great syrup and they want you to taste it. So I was in Minnesota and I had a man and wife give me a sample of the syrup that they made, and they said they wanted to take a taste of it. And so, really, the first thing you do when you judge syrup or check it for flavor, you smell it first. And I could notice a kind of a perfumey aroma when I smelled the syrup, and I was kind of interested to see what this was going to taste like. So I smelled it, could smell a little bit of that perfumey aroma, and then I took a taste of it, and you could taste kind of like a soapy flavor almost to that syrup. So I asked them, I said, so what is your process for filtering? And they said, well, we use filter bags. And I said, okay, so what are you doing to wash your filter bags? Well, we wash them or rinse them out with hot water, and then I throw them into the washing machine, but without any soap. Well, there's enough soap residue left in that washing machine that she washed it through that cycle with just enough hot water that it could pick up that soap flavor in that maple syrup. There was enough soap left in that filter bag. So, like say, wash with hot water only, and like say, make sure we get them, completely dry before we get them put away, so that we don't end up with a musty smell. Threadbare and bags should be replaced. Um, they won't filter all the sugar sand out. We'll have a little cloudiness. Um, as crazy as this may sound, give your filter bag the sniff test. So a lot of times, what happens is people will wash them in hot water. They think they got them dry, and they'll stick them in a plastic tote in an airtight container. And then when they take them out the next time to use them, they've got kind of a musty or a mildewy smell to them. Okay, they weren't put away dry. So, like say, smell that filter bag. If it's got a musty or mildewy, odor to it, we definitely want to replace that filter bag because that will definitely transfer into your syrup. So, okay, now we're going to talk a little bit about bottling syrup. So never cold pack maple syrup. So years ago, we would see a lot of cold packing of maple syrup. 30 years ago, we don't really see that much in today's world or by today's standards. We always want to make sure we're hot packing that syrup. The safest minimum temperature to bottle or package your syrup is going to be 180. Okay. So like I mentioned before, we want to stay below 200 degrees to make sure that we're not generating that sugar sand or niter again. Okay, so we're going to talk about plastic containers. So make sure containers are at room temperatures. Make sure the seals are in the cap. So typically, On our maple syrup jugs or bottles, there will be a seal that is located in the cap of that container. Okay, so make sure that seal is in there. So when we talk about plastic containers, um, every bottle manufacturer in the world has figured out the more I can make more money making plastic bottles if I make the plastic thinner. Okay. So when we look at the plastic bottles that we use in the maple syrup world today versus what we had 30 years ago, the bottles are much thinner. Okay. And if I take a bottle like this filled with hot maple syrup and I lay it down on its side for a number of minutes, what will happen to that bottle of syrup is I will flat side that container. And in a lot of cases, I will wreck the heat activated seal in the cap and I will have syrup run out the cap. Okay, so we're going to kind of discuss some practices for bottling just based upon on what we see in the container world today. So when we talk about headspace in a container, if we're going to have a problem with a bottle of syrup, it will be in what we call the headspace of the container. So, and this one here is kind of hard to see. The liquid level is right here, and of course, the top of the bottle is here. So it has a very short headspace. So when we're filling maple syrup jugs, we want to fill that jug all the way to the top because when it cools off, it's definitely going to shrink. It is that gap or that headspace, depending on the sanitation of my maple syrup operation, will depend if I grow mold in that area of that container. Okay, so we're going to talk about a couple things there. So make sure the caps are seated with the proper torque. Now, when we talk about that, when we go on to plastic maple syrup jugs, if we tighten to the point where we get it good and tight or snug, you probably want to quit because if I go just a little bit more, it's going to jump a thread because that bottle is hot. It's filled, of course, with 180-degree syrup. The plastic is thin. Okay, so like I say, get it on, get it snug, and then what I'm going to tell you is lay the bottle on its side because I want some syrup up in that headspace to sanitize that cap and sanitize the neck area of that bottle. I'm going to go 5, 4, 3, 2, 1, and I'm going to stand that bottle back up. The reason that I'm going to stand that bottle back up is we have heat activated seals. If I lay that bottle on its side for too long, I disrupt that heat activated seal and I start to lose the bonding of the seal to the top of the bottle. Okay. So like I say, I am old school. I do want to get them on their side for about 5 seconds. We get that hot syrup up in that neck area, in that cap area of that bottle, but then I want to get them stood back up again so that I don't have any issues. Like I say, if I leave that on its side for a prolonged period of time, I'll disrupt that seal and I'll see some syrup kind of leaking out that cap. So, okay, like I say, lay it on their side. Like I say, minimum of 180 degrees. Okay, so that really kind of is the key. So we're going to talk about glass containers. So when we talk about glass containers, glass absorbs a tremendous amount of heat. Okay, so of course I want my bottles at room temperature. Okay, but I want my syrup temperature a little hotter, about 190 to 195. I want to stay below 200 so that I'm not making that sugar sand, so I get that cloudiness appearance back in my syrup. But like say, I want to get it hotter because that glass is going to suck up a lot of the heat from my syrup. Make sure the seals are in the cap. So if you're using a glass maple syrup bottle, really the 4 common bottles that we use for bottling syrup are going to be our pint and quart decanters, which have flip top, pour top caps, and then our 8 and 12 ounce little flask bottles or flat bottles with the handles on, and those usually run a pour top cap as well. If you are using a bottle with a pour top cap, whether it's the pint and quart decanter, the 8 or the 12 ounce, those are all heat activated seals as well. So I'm going to say on your side for 5, 4, 3, 2, 1, and then get them stood back up. I want that syrup in that neck area, in that head area of that bottle to sanitize it, but I don't want to leave it there for a prolonged period of time where I get rid of that glue seal. So that's kind of the long and the short about bottling into containers. Now we're going to talk about a couple more things. Yep, go ahead, Shane.
What's the proper torque?
Well, so proper torque. When we look at, we had talked about that a little bit with the plastic jugs. Get them snug. Okay. Same thing with the glass bottles. They're a smooth cap. It's really hard to over tighten them. So get them tightened up by hand as tightly as you can. It's not like the old plastisol metal caps that we used to use years ago. We would put them on the containers and we would give them a little extra torque with a pair of pliers. We can't do that with the containers today. Like I say, get them on good and snug. If they're on their side for 5 seconds and I don't have any leakage out of that cap area, we're good. So, okay. We're going to talk a little bit about storing your maple syrup, okay? Of course, storing syrup, it would be nice if we could store it somewhere where it's cool, somewhere dark. That would be ideally the best place to store syrup. A lot of times, what I see is somebody has a little sugar shack out in their backyard, a little tin building. In the summer, it'll be 140 degrees in the afternoon, and it'll be 40 degrees at night. So we get some really big temperature swings inside that building. The problem is I grow condensation or moisture in that neck area of that bottle. So that condensation will run down the sidewall of that bottle and it'll lay on the surface of that maple syrup. It won't mix back in. So depending on my sanitation practices, where I made my syrup, the environment that that syrup was made in, if my sanitation practices were good, I won't have any issue. If my sanitation practices were kind of iffy, there's a good possibility I'm going to grow mold on top of that syrup. Now, if I grow mold on top of the syrup, there was a thing years ago that said, if harmless mold grows on top of the syrup, skim it off, bring it back to a boil, your syrup is good as new. It's not really the case. All of that verbiage that we used to see on maple syrup jugs like that years ago has disappeared. And it is to the fact that there are people out there that have mold allergies.